Hello and welcome. I'm truly delighted you're here. Before we get underway, I'd love for you to share in the comments where you're tuning in from and what time it happens to be in your part of the world. It's always such a joy to see this community come together across places and time zones. I also want to take a gentle moment to thank everyone who's subscribed and shown support through likes on the videos. It helps me know what you value most, and it helps others find this space too. Please feel free to leave your ideas for future topics in the comments. Now, let's begin. Chapter 1: Measuring Disorder in Physical Systems. Close your eyes and feel the slow pulse of time beneath your feet. Imagine a single drop of water falling through the air, a silent traveler on its journey toward the earth. This simple motion, this gentle descent, holds a secret that shapes everything from the rustle of leaves to the silent expansion of galaxies. Time flows in one direction only, a river carving its path through the universe. But what makes time flow forward and not backward? What invisible force guides the dance of atoms and molecules toward a future that feels inevitable? This chapter explores the quiet language of disorder, the subtle measurement that reveals time's direction and the hidden rhythm of change in the world around us. Entropy, a word that sounds complex but holds profound simplicity, is the measure of randomness within a system. Think of it as the universe's natural tendency toward becoming less organized, less structured. When you open a door and let the wind rush through, the air becomes more chaotic, more disordered. Entropy quantifies this increase in randomness, a subtle shift that transforms order into chaos. It is not a force, not a push, but a description of how possibilities spread across the world. Entropy is the quiet whisper of the universe saying, "This state of things is more probable than that one." Picture a room with a single book lying on the floor. The book has fallen from a shelf, its pages scattered across the floor. This is a state of disorder. Now imagine the same book carefully placed back on its shelf, pages aligned and neat. That is a state of order. The difference between these two states is measured by entropy. The scattered book has higher entropy than the book on the shelf. Entropy rises when substances mix, a process that feels natural and inevitable. When you pour milk into coffee, the milk and coffee blend together, creating a uniform mixture. This blending is a clear example of entropy increasing. The milk molecules, initially separate and distinct, become mixed with the coffee molecules, spreading out and interacting in countless ways. The system moves from a state of low entropy, where the milk and coffee are clearly separate, to a state of high entropy, where they form a single, uniform mixture. This blending is not random. It follows a natural law. The number of ways the milk and coffee molecules can be arranged together is vastly greater than the number of ways they could remain separate. Entropy, in essence, counts the number of possible arrangements that a system can take. When you mix two substances, you create many more possibilities than before. The coffee becomes less predictable, the milk less distinct. This is the universe speaking through the language of probability. As the great physicist Ludwig Boltzmann once explained, entropy is the number of possible microscopic configurations that a system can have. This simple idea, rooted in the behavior of atoms and molecules, reveals the deep connection between disorder and the flow of time. Entropy's rise defines the arrow of time. We experience time moving forward from the past to the future, but this direction is not obvious. Why does time flow in one direction and not the other? Why does an egg break but never spontaneously reassemble? The answer lies in entropy. The second law of thermodynamics states that in any closed system, entropy tends to increase over time. This increase in disorder is what gives time its direction. When you drop an egg, the shell shatters, the pieces scatter, and the system becomes more disordered. The entropy of the egg increases. This process happens naturally, without external energy, and it moves the system toward a state of higher entropy. The egg cannot reassemble itself because that would require a decrease in entropy, a reversal of the natural flow. Entropy's increase is not a sudden event but a slow, steady progression. It is the gradual shift from order to disorder that shapes the world. When you watch water flow from a tap into a bowl, the water spreads out, filling the bowl with a smooth, uniform surface. This is entropy in action. The water molecules move from a confined space to a more spread-out state, increasing the system's randomness. The process feels natural, inevitable, and irreversible. Once the water has spread, it does not spontaneously return to its original state. This slow movement toward disorder is the quiet rhythm of time itself. Consider the mixing of gases. Imagine two different gases, say oxygen and nitrogen, held in separate containers. When you connect the containers, the gases mix, spreading out to fill the entire space. The oxygen molecules move through the nitrogen, and the nitrogen molecules move through the oxygen. This mixing creates a uniform mixture, a state of high entropy. The gases do not separate again because the system has moved toward a state of maximum disorder. This process is irreversible and happens naturally, without any external intervention. The universe, in its vastness, constantly moves toward greater disorder, a silent process that defines the direction of time. Entropy's rise is also visible in the behavior of everyday objects. Think about a cup of hot tea left on a table. As it cools, the heat transfers from the tea to the surrounding air. The tea becomes less hot, the air becomes slightly warmer. This transfer of heat is a slow increase in entropy. The hot tea loses order as its molecules spread out and interact with the cooler air molecules. The system moves toward a state of equilibrium where the temperature is uniform throughout. This process is slow, but it is inevitable. The tea does not spontaneously reheat, it cools because entropy increases. Entropy's role in the universe is profound. It is the reason why stars burn, why planets orbit, and why life exists. Stars burn because they convert mass into energy, releasing heat and light. This process increases the entropy of the universe. The energy released by stars spreads out into space, creating a more disordered state. Without this increase in entropy, stars would not burn, and the universe would not evolve as it does. Planets orbit stars because of the gravitational pull, but this motion also involves an increase in entropy. The gravitational interaction between celestial bodies creates a slow, steady flow of energy and matter, driving the system toward greater disorder. Life itself depends on this process. Living organisms maintain order through constant energy input, but they ultimately contribute to the increase in entropy. The heat generated by metabolic processes spreads out, creating a more disordered state. The concept of entropy is not abstract. It is found in the smallest details of the universe. At the atomic level, particles move randomly, colliding and bouncing off each other. These collisions create a state of high entropy. When particles interact, they spread out, increasing the number of possible arrangements. This spreading out is the essence of entropy. The more particles move freely, the higher the entropy. This is why the universe appears to be moving toward a state of greater disorder. The stars, planets, and galaxies are all part of this slow, inevitable process. Entropy's increase is also a measure of the universe's potential for change. When you open a door, the air rushes in, creating a more disordered state. When you drop a book, the pages scatter, increasing the number of possible arrangements. These small changes, though seemingly insignificant, are part of a larger pattern. The universe is constantly evolving, moving toward greater disorder. This movement is not random, it follows the laws of physics. Entropy is the quiet language of the universe, speaking in the language of possibility and probability. As physicist Sean Carroll has noted, The arrow of time is the direction of increasing entropy. This statement captures the essence of why time flows in one direction. When entropy increases, time moves forward. When entropy decreases, time would move backward. But entropy decreases only in very specific, rare circumstances, like the formation of a snowflake. These events are exceptions, not the rule. The vast majority of processes in the universe follow the path of increasing entropy, creating a consistent direction for time. Imagine a single drop of ink falling into a glass of water. The ink spreads out, creating a pattern that changes over time. At first, the ink is concentrated in one spot. Then it spreads, becoming more uniform. This spreading is an increase in entropy. The ink molecules move from a state of low entropy to a state of high entropy. The process is slow, but it happens naturally. The ink does not reassemble itself because that would require a decrease in entropy, a reversal of the natural flow. This simple experiment reveals the quiet power of entropy. Entropy's role in the universe is not limited to the physical world. It shapes the behavior of living systems as well. Cells maintain order through processes that require energy. But these processes also generate heat and increase entropy. The energy used by cells spreads out, creating a more disordered state. This increase in entropy is what allows life to exist. Without it, life would not be possible. The balance between order and disorder is delicate, but it is maintained by the constant increase in entropy. Entropy's rise is also a measure of the universe's future. As the universe expands, the number of possible arrangements increases. This expansion leads to a state of maximum entropy, a heat death, where the universe becomes a uniform, cold state. This is a natural consequence of entropy increasing. The universe is moving toward this state, a slow process that will take billions of years. But even in this distant future, the increase in entropy will continue, shaping the universe's evolution. Entropy's influence is felt in the smallest details of daily life. When you wake up in the morning, the light from the sun fills your room. The light spreads out, creating a more disordered state. When you walk outside, the air feels warmer, the molecules moving more freely. This increase in entropy is part of the natural flow of time. The universe is constantly changing, moving toward greater disorder. This process is not chaotic. It is the quiet rhythm of the cosmos. Think about the moment you open a window. The cool air rushes in, mixing with the warmer air inside. This mixing creates a state of high entropy. The air becomes less organized, more random. This process is irreversible. The air does not spontaneously return to its original state. This is the universe's way of ensuring that time flows in one direction only. The increase in entropy is what makes the past distinct from the future. Entropy's rise is not a sudden event but a continuous process. It happens in the blink of an eye, in the slow movement of a glacier, in the silent expansion of the universe. It is the quiet language of the cosmos, speaking in the language of possibility and probability. As you breathe, feel the slow rhythm of time, the gentle increase in disorder that shapes your world. This is the universe's way of moving forward, one small increase in entropy at a time. The increase in entropy reveals why time flows in one direction. It is the quiet language of the universe, the silent measure that tells us how disorder grows. When you mix substances, when you watch water flow, when you see a star burn, you are witnessing entropy at work. This process is not random. It is the natural progression of the universe toward greater disorder. It is the reason why time has a direction, why the past is fixed and the future is open. This slow dance of disorder is the quiet rhythm of time itself. It is the reason why an egg breaks but never reassembles, why coffee and milk blend but never separate again. As you close your eyes and feel the slow pulse of time, Remember that entropy is the universe's measure of disorder, the silent force that defines the direction of time. This understanding leads us naturally to the next chapter, where we will explore why entropy always increases, the deep reason behind the universe's relentless march toward greater disorder. Chapter 2: Why Entropy Always Increases. Imagine a single ice cube resting in your palm, cool and smooth against your skin. Feel its sharp edges, the way it seems to hold the entire winter within its crystalline structure. Now watch it melt slowly, steadily, as the warmth of your hand seeps into its frozen heart. You might not notice it at first, but the ice cube's journey from solid to liquid is a tiny, silent rebellion against order. It is a perfect illustration of why time moves only forward in the universe, a reason that feels almost magical, yet is rooted in the quiet language of physics. This is the story of why entropy always increases, and why the universe, like a single melting ice cube, finds itself steadily sliding toward greater disorder. Think about a sealed container of gas. If you leave it alone, its molecules will spread out, filling every corner of the space, until they move randomly and chaotically. This is what happens in isolated systems, systems that have no outside influence. Over time, these systems naturally become less ordered, more disordered. The gas molecules stop moving in neat patterns and instead scatter everywhere, their energy distributed in a way that feels messy and unpredictable. This shift from order to chaos is not a choice. It is the universe's natural tendency. It is the quiet hum of entropy at work, a process that shapes everything from the slow cooling of stars to the gentle collapse of a snowdrift. Isolated systems, like the sealed container, always move toward greater disorder without needing outside help. This is the first rule of time. It only flows in one direction because the universe, left to itself, always becomes more disordered. Now close your eyes and feel the chill of that melting ice cube. As it melts, the water molecules break free from their rigid, repeating patterns. They slide past each other, moving freely and randomly. This is entropy in action, a measure of disorder that increases as the ice cube dissolves. You can almost hear the soft asterisk plink as droplets form and fall. The ice cube's journey from solid to liquid is a small but powerful example of why time moves only forward. In this moment, the system, the ice cube and the water it becomes, has lost its initial order. The molecules that were locked in a precise, stable arrangement are now free to move anywhere. This shift is not sudden or forced. It happens naturally, quietly, as the ice cube's energy flows toward a state of greater randomness. The melting ice cube is a tiny universe, a miniature demonstration of how all systems, left to themselves, gradually become less structured. Energy flows from hot to cold without needing any outside help. This is how the universe works. When you hold a cup of hot coffee, its heat naturally flows toward the cooler air around it. The coffee cools down and the warmth spreads into the room. You don't need to do anything, no pump, no machine, no extra energy to make this happen. The heat moves from the hot coffee to the cooler air, spreading out until the temperature becomes more uniform. This is spontaneous, effortless energy transfer. It is the same process that drives the melting ice cube. The heat from your hand flows into the ice, warming it until it becomes liquid water. This natural flow from hot to cold is the quiet engine of entropy. It is the reason why time moves only forward. Without this constant, unforced movement of energy toward disorder, the universe would be stuck in a state of perfect order, frozen in time. Why does this happen? It has to do with the way energy and matter interact. In the early universe, everything was incredibly dense and hot, a state of near-perfect order. But as the universe expanded, it began to cool, and the energy within it started to spread out. This spreading out is entropy in action. Think about the stars forming from clouds of gas. At first, the gas was tightly packed, moving in a coordinated way. As gravity pulled the gas together, it became more ordered, but eventually, the energy within the system began to dissipate. The stars burned, their light spreading out, their heat flowing into space. This process of energy dispersing and becoming more disordered is what gives time its direction. Entropy is not just about melting ice or cooling coffee. It is the silent force that shapes the entire universe. Consider the slow dance of a river. Water flows from high to low, carving paths through the land, creating valleys and canyons. This movement is not random. It is a process of energy moving from a more ordered state to a less ordered one. The river's path becomes more complex, more chaotic as it flows. This is entropy in action. The river's journey is a quiet reminder that time moves only forward because energy and matter naturally seek greater disorder. You might wonder why entropy increases at all. Why doesn't the universe stay in a state of perfect order? The answer lies in the nature of energy itself. Energy has a tendency to spread out. When energy is concentrated in one place, it is more ordered. But as it spreads, it becomes less ordered, more disordered. This is why heat flows from hot to cold, why ice melts, why stars burn out. Energy always seeks the path of least resistance, the path that leads to greater disorder. This is the fundamental reason why time moves only forward. Think about the slow process of a snowflake forming. It starts as a single water molecule, then another, building a delicate, intricate pattern. But once the snowflake is complete, it falls to the ground, melting into the earth. This melting is a tiny example of entropy increasing. The snowflake structure is highly ordered, but once it touches the ground, it breaks down into water that spreads out, becoming less structured. This is the same process that happens in the entire universe. Every time energy spreads out, it becomes more disordered. Every time a system loses its order, it moves closer to the state of maximum entropy. Here's where it gets fascinating. Entropy doesn't just happen in the lab or the kitchen. It happens everywhere. In the deep ocean, where cold water meets warm currents, the energy flows from the warm to the cold, creating a slow, steady movement. In the human body, heat flows from your skin to the air around you, a process that keeps you comfortable without any external effort. Even the slow heartbeat of the Earth, the constant movement of tectonic plates, is driven by entropy. These are not random events. They are the quiet, natural progression of energy moving toward greater disorder. Entropy is not a force that fights against time. It is the reason time moves only forward. It is the quiet language of the universe, speaking in the language of disorder. When you see a drop of water falling from a leaf or a cloud drifting across the sky, you are witnessing entropy in action. The universe is constantly becoming less ordered, more chaotic, and this is why time moves only in one direction. You might ask, why does this process feel so slow? Why don't we notice it more? The answer is that entropy increases so gradually that it feels almost invisible. A single ice cube melting takes hours. A cup of coffee cooling takes minutes. The universe itself has been expanding for billions of years, and its entropy has been increasing steadily. This slow, steady increase is what gives time its direction. It is the reason why we remember the past, but not the future. It is the reason why events unfold in a sequence that feels unidirectional. Entropy is not a random force. It is a fundamental principle of nature, woven into the very fabric of the universe. It explains why the universe has a direction, why time moves only forward. It is the quiet rhythm that drives everything from the melting of ice to the slow collapse of stars. This rhythm is not something we can control or stop. It is the universe's natural state, the way energy and matter interact to create a world that feels alive and ever-changing. Consider this: the next time you see a sunset, think about the energy flowing from the sun to the earth. The heat from the sun travels through the atmosphere, warming the land and sea. This energy spreads out, becoming less concentrated, less ordered. It is the same process that happened when the first stars formed in the early universe. The energy that once was tightly packed in the core of a star now flows outward, spreading into space. This is entropy at work. It is the quiet engine of time's forward motion. Why does this matter? Because understanding entropy helps us see how time works. It tells us why we can't go back in time, why we remember the past but not the future. It explains the slow, steady movement of energy through the universe. This is not a complex idea, it is something we experience every day. The melting ice cube, the cooling coffee, the rising sun, all are part of the same story. They are all examples of why entropy always increases and why time moves only forward. Entropy is the universe's quiet heartbeat. It pulses steadily, slowly, without interruption. It is the reason why the ice cube melts, why the coffee cools, why stars burn out. It is the reason why time moves only in one direction. This steady increase in disorder is what gives the universe its direction. It is the reason why we feel time passing, why we experience the world as it unfolds. So next time you feel the chill of a melting ice cube or the warmth of a cooling cup, remember this. You are part of a vast, quiet process. The universe is always becoming more disordered, and this is why time moves only forward. This slow dance of entropy is the reason why the universe has a direction, why we experience time as it flows. It is the quiet language of the cosmos, speaking in the language of disorder. This steady increase in entropy is not a problem to be solved. It is the universe's natural state, the way energy and matter interact to create a world that feels alive and ever-changing. It is why time moves only forward, why we remember the past but not the future. It is why the ice cube melts, why the coffee cools, why stars burn out. As we sit here, feeling the quiet warmth of the sun on our skin, we are part of this process. The universe is expanding, its energy spreading out, becoming less ordered. This is the story of why time moves only forward. It is the story of why entropy always increases. It is the story of why the universe has a direction. This slow, steady increase in disorder is the reason why time flows as entropy grows. It is the quiet rhythm that guides everything from the melting ice cube to the slow collapse of stars. This is the reason why we experience time as it moves. This is why the universe has a direction. As you close your eyes and feel the warmth of the sun on your skin, remember this. Time moves forward because entropy increases. The universe is a slow, steady dance of disorder, and this dance is what gives time its direction. This is the quiet story of why the universe has a forward flow, why we experience time as it moves. This is why the ice cube melts, why the coffee cools, why stars burn out. This is why time moves only forward. Chapter 3. Time flows as entropy grows. Imagine the quiet rhythm of a river flowing downstream, its water carrying the weight of mountains into the sea. This gentle movement, this unbroken progression, is a silent echo of time itself. Time does not simply pass, it flows, and its direction is defined by something profound and universal: the quiet expansion of disorder within the universe. We call this expansion entropy, and it is the invisible hand that guides time's one-way journey. Picture a single drop of water falling from a leaf. As it descends, it spreads out, becoming less distinct, less focused. This is the beginning of entropy in action. The universe began in a state of extraordinary order, like a perfect, intricate clockwork mechanism. But as time passed, that order slowly dissolved. The past held moments of remarkable clarity, moments where things were more neatly arranged, more predictable. Think of a cup of coffee that was still and hot, its molecules vibrating in unison. Now, imagine it spilled on the table. The coffee spreads, the molecules scatter, and the system becomes less organized. This shift from order to disorder is the essence of entropy, and it happens everywhere, from the smallest particle to the vastness of the cosmos. The arrow of time points toward this growing disorder. It does not move in circles or loops. Time flows forward because the universe naturally progresses from states of lower entropy to states of higher entropy. This is not a choice or a force we can control. It is the fundamental way energy and matter interact. When you watch a sunset, the light softens and fades into the horizon. When you listen to the wind through trees, it carries whispers of the past. These moments are not random. They are part of the universe's quiet journey toward greater disorder. The arrow of time is the direction we feel, the path we travel, and it points steadily toward increasing entropy. Ludwig Boltzmann, the brilliant physicist who first grasped this concept in the late 19th century, described entropy in terms that feel both scientific and deeply human. He imagined the universe as a vast garden where the seeds of order slowly sprout and then inevitably fade. The tendency of the universe, he wrote, is to move toward a state of maximum disorder, a state where all things are mixed and unconnected. His words hint at something profound. Time's flow is not arbitrary. It is the natural consequence of how energy distributes itself. When we observe the world, we see this movement like a slow, steady breath. The past was a moment of calm, a place where things were more tightly held together. The present is the gentle unspooling of that order, the quiet expansion that defines how time moves. This growth of entropy is what makes time feel unidirectional. It explains why we remember the past but not the future, why certain events unfold in a specific sequence. Think of a single grain of sand in an hourglass. As time passes, the sand falls, becoming less concentrated, less precise. It never rises back up to its original position. This simple image captures the essence. The universe moves from order to disorder, and this movement is time itself. The past is a state of lower entropy, a place of greater structure and clarity. The present is the moment where that structure is gently dissolving. The future holds even more disorder, a landscape of increasing complexity and chaos. Why does this matter so deeply? Because it reveals the deep connection between time and the physical world. Entropy is not just a number or a concept, it is the quiet pulse of reality. When you feel the warmth of sunlight on your skin or the coolness of rain on your face, you are experiencing the universe's natural progression. This flow is the reason why time feels real and meaningful. Without it, there would be no past, no present, and no future, only a static, unchanging state. The growth of entropy creates the illusion of time's passage, the sense that we are moving through a river of moments. Carl Sagan, the astronomer who made the cosmos feel intimately close, understood this connection beautifully. He wrote, "The universe is a vast, intricate machine, but its most fundamental law is not one of perfect order. It is the gentle, inevitable flow toward disorder." Sagan's words remind us that time is not a linear path we walk alone. It is a shared journey, a slow dance between order and chaos. The more we understand entropy, the more we see how time is woven into the fabric of existence. It is the quiet rhythm that allows us to feel the passage of moments, to sense the universe's steady transformation. This unidirectional flow defines time's direction in a way that is both simple and profound. It is the reason why we experience time as moving forward, why we cannot reverse the flow of a river, why broken glass does not reassemble itself. Entropy is the silent force that ensures time has a single, clear path. It is the reason why the past is fixed and the future remains open, yet always shaped by the quiet expansion of disorder. This growth is not random. It is the universe's gentle embrace of change. As we sit with this idea, imagine the universe as a vast, slow heartbeat. Each beat pulses with the expansion of entropy, the quiet increase of disorder. This is time's true nature, not a force we control, but a natural process that guides all things. The past was a moment of stillness, a place where order held its breath. The present is the gentle release of that breath, the slow unspooling of energy. The future is the next sigh of the universe, a quiet expansion that will continue ever onward. Now, as we gently trace the path of time's flow, we are not lost. We are part of this vast, quiet journey. The growth of entropy has already written the story of time's direction. It has shown us that every moment is a step toward greater disorder, a step that defines the way we experience the world. This understanding is not a burden but a quiet gift, a reminder that time flows as entropy grows, and that within this flow, we find our place. The path ahead is clear, and the universe's gentle rhythm continues, steady and sure. This unidirectional flow is the heart of thermodynamics. The second law of thermodynamics states that in an isolated system, entropy always increases over time. It is this law that gives time its direction. Imagine a sealed room. If you drop a book, it falls to the floor. The book was once in a state of order, on a shelf, then it becomes disordered as it lies on the floor. This shift from order to disorder is not random. It is the natural progression of the system toward higher entropy. Ludwig Boltzmann, the brilliant physicist who helped us understand the statistical nature of entropy, once mused, "The arrow of time is the direction in which the universe's entropy increases." His words, spoken in the quiet of his study, remind us that time's flow is not arbitrary, but a consequence of the universe's inherent tendency toward disorder. Boltzmann saw the cosmos as a vast collection of particles, each moving with purpose that, over time, leads inevitably to a state of maximum disorder. This increase in entropy is what makes the future different from the past. In the early universe, matter was concentrated in high-order states, stars forming, planets coalescing, life beginning. Now, the cosmos is becoming less ordered. Stars burn, planets orbit, and the Earth's heat flows into the atmosphere. This slow, inevitable rise in disorder defines time's direction. For us, this flow of entropy is not an abstract concept but a tangible experience. When we wake in the morning, the world feels fresh and ordered, beds made, sun rising, air clear. But as the day progresses, the world becomes less ordered. Coffee cools, leaves fall, light fades. This daily cycle is a small example of the universe's entropy increase. Have you ever felt the universe's breath? It is the slow release of order we experience as time. The past was a moment of stillness, the present is the gentle release, and the future is the next sigh of entropy. This is the story of time's flow, written by the growth of disorder. What if time were not a river but a static landscape? Without the flow of entropy, there would be no past, no present, and no future. The universe would be frozen in a state of perfect order, and life as we know it would never begin. But because of the arrow of time, we have a story to tell, one that unfolds as entropy grows. This understanding brings deep peace. We are not lost in time. We are part of a natural process that has unfolded for billions of years. The universe's rhythm continues, steady and sure. As we move through the present, we are part of a grand story written by the quiet force of entropy. Each moment we experience is a step toward greater disorder, a step that defines how we live and see the world. This growth of entropy is not limited to Earth or even our solar system. It is a universal process affecting the entire cosmos. From the birth of stars to the death of galaxies, entropy increases. The universe began in a state of high order, almost a perfect singularity, and has been expanding and cooling ever since. As it cools, the cosmos becomes less ordered, stars burn out, leaving behind remnants of matter and energy. This slow dance of entropy is the story of the universe itself. This process has been ongoing for billions of years and will continue for billions more. The increase in entropy is the reason the universe has a past, present, and future. It is the reason we can experience time and build stories of our lives. Without this flow, there would be no life, no consciousness, no meaning. But with it, we have a story that is both profound and peaceful. The universe's gentle rhythm continues, and with it, time flows as entropy grows. The past holds a state of greater order, a moment when the universe was more compact and stable. Now, as we live in the present, the cosmos has expanded and become less structured. This steady shift from order to disorder is the unidirectional flow of time itself. Ludwig Boltzmann, the brilliant physicist who laid the groundwork for our understanding of entropy, explained that the universe naturally progresses toward states of higher disorder. This principle, known as the second law of thermodynamics, defines the arrow of time. Without this constant increase in entropy, the universe would have no direction, no past, no present, no future. Have you ever felt the gentle pull of time? It moves us from order to chaos, from the compact singularity to the vast, dispersed universe. Each moment is a step in the universe's natural progression, a quiet journey toward greater entropy. This flow is the reason we experience a linear time, a story that is both profound and peaceful. As the universe expands, it continues to grow in entropy, and time moves forward in a steady, soothing rhythm. Chapter 4: Scientists Unraveled Entropy's History. Imagine the quiet hum of a single stone resting on the riverbank. Feel how its surface catches the morning light, smooth and cool beneath your fingertips. This gentle touch is a tiny reminder that even the smallest things hold stories waiting to be heard. In the quiet spaces between the rustling leaves and the distant song of birds, scientists have spent centuries tracing the invisible currents that shape our world. Today, we explore how the universe's quiet unfolding, how time itself moves in one direction, was revealed through the careful study of entropy. This journey begins with a single word, a concept so profound it rewrote the very meaning of change. Rudolf Clausius first defined entropy in 1850, a year when the world still felt the weight of the Industrial Revolution's steam engines and the slow pace of human thought. He was a German physicist working in the shadow of the great scientific shifts happening in Paris and Berlin. Clausius sat in his laboratory, surrounded by the scent of ink and coal smoke, and began to see patterns in the heat that flowed from one place to another. He noticed how energy, once concentrated in a single spot, would spread out and dissipate into the air, the water, the very fabric of the world. This was not random. It was a slow, inevitable process. Clausius called this spreading of energy entropy. He wrote it down in a series of elegant equations, but what truly mattered was the idea that the universe has a natural tendency to become less organized, less structured. Think of it like a garden left to its own devices. Flowers once neatly arranged will gradually drift apart, petals falling, roots spreading, until the garden is a tangled mess of life and decay. Clausius understood that this process was not a choice, but a fundamental feature of how the world works. He saw that the more heat energy spreads across a system, the more disordered it becomes. This was the first step in understanding why certain things happen and why others do not, why the universe moves in one direction, not two. Clausius's work was revolutionary, yet it was only the beginning. A few decades later, Ludwig Boltzmann, an Austrian physicist living in the quiet hills of Vienna, took this idea and gave it a deeper, more personal meaning. Boltzmann was a man who loved the beauty of the natural world and the quiet moments of observation. He spent his days watching the movement of gas molecules in a laboratory, imagining how they danced and collided in the invisible spaces between atoms. Boltzmann realized that entropy was not just a measure of heat spreading out, it was a measure of the number of ways a system could be arranged. The more ways the molecules could move, the higher the entropy. He saw the universe as a vast tapestry of possibilities, each thread a molecule in motion. When the molecules were orderly, like soldiers in perfect formation, the entropy was low. When they became chaotic, like a storm of wings and wind, the entropy was high. Boltzmann's insight was profound. The universe is constantly shifting toward greater disorder, a slow, steady drift toward chaos. He wrote, "The entropy of a system is the logarithm of the number of microstates it can occupy." This simple phrase described a world where every action, every shift in energy, contributes to a single, inevitable direction. Boltzmann's ideas were not just abstract, they were deeply connected to the physical world around us. He understood that this shift toward disorder was not a sudden event, but a slow, continuous process. Think of a cup of coffee left on a table. It starts hot, its heat concentrated in the liquid. Over time, the heat spreads into the air, the table, even the room. The coffee cools, its molecules move farther apart, and the system becomes less organized. This is entropy in action. Boltzmann saw this daily phenomenon as a universal truth. He knew that even the smallest particles in the universe were following the same path toward greater disorder. This was the key to understanding time itself. The universe does not move in circles or loops, it moves in one direction, from order to chaos. But how do we know this? How do we see the quiet flow of entropy in the world? Scientists have long sought answers, and one of the most intriguing questions came from James Clerk Maxwell, a Scottish physicist who lived in the 19th century. Maxwell imagined a thought experiment that would challenge the very idea of entropy. He pictured a room full of gas molecules, some moving fast and in straight lines, others drifting slowly and erratically. He then imagined a tiny, intelligent being, what he called a demon, that could observe the molecules and move them in a way that would create order. This being could, for example, let fast-moving molecules pass through a barrier while blocking slow ones, effectively cooling the gas and creating a more organized state. At first glance, this seemed like a way to reverse entropy. But Maxwell quickly realized that the demon itself would need to work against the natural flow of heat. The demon would have to absorb energy to observe the molecules, and that energy would eventually spread out, increasing entropy again. In the end, the thought experiment showed that even with such a clever being, the universe's tendency toward disorder would prevail. Maxwell's demon was not a real machine, but a powerful idea that helped scientists see how entropy works at a deeper level. It revealed that the universe's flow toward disorder is not a limitation, but a natural rhythm. The demon's attempts to create order were like trying to build a sandcastle in a storm. Eventually, the energy used to shape the sand would be dispersed, and the castle would collapse. This idea connected entropy to the very nature of time. Scientists realized that the arrow of time, the way we experience the past, present, and future, was rooted in this constant shift toward disorder. The past was more ordered, the present is a moment of transition, and the future is increasingly chaotic. As we consider these ideas, it becomes clear that entropy is not just a concept for physicists. It is a quiet force that shapes every moment of our lives. Think about the warmth of a stone in your hand. The heat from your body spreads into the stone warms, and the energy moves outward. This is entropy in action, energy spreading, becoming less concentrated, moving toward a state of greater disorder. Even the slow fading of a candle flame, the gentle release of a sigh, the quiet settling of a leaf on the ground, all these are tiny examples of entropy. They are part of the same story, the same slow unfolding of time. The beauty of entropy lies in its simplicity and its universality. It does not care about human intentions or grand designs. It is a quiet, steady force that works across the entire universe, from the smallest grain of sand to the vast expanse of space. When we feel the warmth of the sun on our skin or the coolness of the night air, we are experiencing the same process that Clausius and Boltzmann studied. Entropy is the universe's way of saying, "This is how energy moves." It is the reason why some things happen and why others do not. This slow, steady shift toward disorder is what gives time its direction. Without entropy, the universe would not have a past, a present, or a future. Time would be a circle, a loop where everything could happen again and again. But because entropy increases, the universe moves in one direction, from order to chaos. This is why we remember the past but not the future, why we feel the weight of history in our hands. The past was more ordered, the present is a moment of transition, and the future is a landscape of increasing disorder. Imagine standing on a hill at dawn. The sun is rising, the air is cool, and the world is still. Now think about what happens as the day unfolds. The sun warms the earth, energy spreads through the plants and animals, and the world becomes more active. But by evening, the energy has dispersed, the sun has set, and the world feels quieter. This cycle of energy spreading and dispersing is entropy in action. It is the same process that shaped the universe, the same process that makes time move in one direction. Scientists have long known that entropy is not just a theory, it is a living part of the world. It is the reason why a dropped cup shatters into pieces rather than reassembling itself. It is why a fire burns until the wood becomes ash. It is why the universe continues to expand, its energy spreading out into the vastness of space. Entropy is the quiet rhythm that guides all these events. As we sit here, feeling the warmth of the sun on our skin, we can almost hear the universe's whisper. It says, "Time moves in one direction because energy spreads out." This is how the world becomes less organized, more chaotic, and more beautiful. It is a process that has been unfolding for billions of years, a slow, steady flow that connects every moment of our lives. This quiet understanding of entropy gives us a new way to see time. Instead of thinking of time as a straight line, we can imagine it as a river flowing toward the sea. The river starts with clear, ordered water like the beginning of the universe, and as it moves, it becomes wider, more turbulent, and eventually reaches the vast, open sea. This is the arrow of time, a constant movement toward greater disorder. The scientists who studied entropy did not see it as a problem to solve, but as a story to tell. Clausius saw the flow of heat, Boltzmann saw the dance of molecules, and Maxwell imagined the tiny beings that could challenge the flow. Together, they revealed that time has a direction because the universe is constantly becoming less organized. This is not a random accident but a natural rhythm, a quiet force that has shaped the world for billions of years. When you close your eyes and feel the warmth of the sun on your skin, remember this. You are part of the same slow, steady flow. The universe's quiet story is written in the language of entropy. It tells us that time moves in one direction because energy spreads out, becoming less concentrated, more chaotic, and more beautiful. This is the story of how the universe unfolds, how time becomes real, and how we are all part of its quiet rhythm. This understanding leads us gently to the next chapter, where we explore how entropy shapes the ordinary moments of our lives, how the heat of a cup of coffee, the rustle of a leaf, and the quiet hum of the world around us are all part of the same story. The universe's quiet rhythm is not just a theory, it is the heartbeat of everything we experience. And as we move forward, we carry this understanding with us. A gentle reminder that time flows in one direction, toward the beauty of the unfolding. Chapter 5: Entropy in Daily Life. Imagine a single drop of perfume released into a quiet room. That tiny burst of scent carries molecules, light as breath, carrying the promise of lavender or vanilla or something sweet and unfamiliar. These particles begin their journey without any push, without any conscious effort. They move through the air, a silent dance, spreading outward in all directions. You might not notice at first, but the scent grows. It becomes less concentrated near where it was released, like a soft wave moving through the space. This is the quiet work of entropy. The perfume molecules, once clustered together in a small area, naturally disperse into the larger space. They spread out, becoming more spread out, more random. This increase in disorder is the second law of thermodynamics at work in the most ordinary place, your living room. The molecules seek a state of greater randomness, a state where their positions and movements are less predictable. You don't have to push the scent to travel further. It happens naturally, effortlessly. This is the invisible flow of time itself, the way disorder increases in the universe. The perfume tells us that things tend toward becoming less organized, less structured, simply by existing. This quiet spreading is a reminder that time moves in one direction, always, toward greater disorder. Now consider a cup of hot coffee left on a kitchen counter. Its warmth radiates into the cooler air around it. You feel the gentle push of heat against your skin, a subtle reminder of the world's energy. But what happens to the coffee? It cools. This cooling is not a sudden event, but a slow, steady process. The heat from the coffee moves through the air, a gentle exchange. The molecules in the coffee, vibrating with energy, interact with the cooler air molecules. They share their energy, transferring it outward. The coffee's temperature decreases. This is the same principle as the perfume spreading, but on a larger scale. The coffee molecules become less energetic, moving more slowly, while the air molecules gain energy. Over time, the coffee cools, becoming less hot, less concentrated heat. The process continues until the coffee reaches the same temperature as the surrounding air. This is equilibrium, a state where there is no further net movement of energy. But this equilibrium is the end point of the process, a point where the coffee is no longer hotter than the air. The coffee cools because the heat flows from a warmer place to a cooler place, a natural movement toward a more uniform state. This is time's irreversible path. The coffee never spontaneously heats up again. Once it cools, it remains cool. The heat flows only one way, from hot to cold. This simple act of cooling demonstrates how time moves forward, how energy disperses, and how order decreases. The coffee cools, and the process is complete. The coffee cools. Think about a piece of fruit left on the counter. It begins as a vibrant, uniform object, its color bright and its texture firm. But then, slowly, changes happen. The skin might become slightly wrinkled. The color fades, losing its vibrancy. The flesh softens, becoming less dense, less structured. This is the quiet work of entropy in action. The fruit is no longer the same as it was. Microorganisms, tiny living things, begin to move into the fruit. They feed on the sugars and other nutrients, breaking them down into simpler substances. This process releases energy, but it also creates more disorder. The fruit's internal structure becomes less organized. The cells that once held the fruit together become less stable. The fruit begins to rot. This is not a sudden event, but a slow, inevitable progression. The food spoils because the molecules within it become more random, more disordered. The energy that once held the fruit together is dispersed, flowing outward in many directions. This is the same principle that applies to the coffee and the perfume. The fruit's internal order decreases as the molecules move more freely, becoming less predictable. The spoilage is a visible sign of entropy. It is the natural progression toward greater disorder. The fruit becomes less structured, less defined. It transforms, not through force, but through the quiet, relentless movement of time. The food spoils, and the process is complete. Entropy is not a force that acts suddenly or violently. It is a slow, gentle process like the quiet breathing of the universe. It is the reason why things become less organized, less structured over time. The perfume spreads, the coffee cools, the fruit spoils. Each of these is a small demonstration of the same principle. This is the second law of thermodynamics, the law that defines time's irreversible path. It tells us that in any closed system, disorder always increases. This is not a random occurrence, but a fundamental truth about how the universe operates. Think about it. Why does the coffee cool? Why does the perfume spread? Why does the fruit spoil? Each of these events shows the same pattern, a natural increase in disorder. This is the quiet movement of time, a constant flow toward greater randomness. It is the reason why things become less organized, less structured, over time. We often think of time as something that moves in a straight line, from past to present to future. But entropy shows us that time has a direction. It moves in one way, always, toward greater disorder. This is why the coffee cools, why the perfume spreads, why the fruit spoils. This is why the universe tends toward chaos, not order. The second law of thermodynamics tells us that the universe is constantly becoming less organized. This is not a bad thing, but a natural part of how the universe works. It is the reason why things change, why nothing stays the same. It is the quiet rhythm of the cosmos, the gentle pulse of time itself. This constant increase in disorder is not something we can stop. It is a fundamental law of nature. It is the reason why life is so rare and so precious. Life exists in a state of relative order, a temporary balance against the constant flow of entropy. This is why life is so fragile, so temporary. It is why life must constantly work to maintain its order, to resist the natural tendency toward disorder. This is where the next chapter begins. Life, in its quiet resilience, finds ways to defend against entropy. It creates structures, it builds complexity, it maintains order. It is a constant battle, a quiet rebellion against the natural flow of time. The universe tends toward disorder, but life, in its astonishing complexity, finds ways to resist. This is the quiet story of how life persists, how it fights against the relentless flow of entropy. Life's quiet rebellion is the next chapter in the story of time. Entropy is not a concept confined to laboratories or distant stars. It is woven into the fabric of everyday life, in the scent of a room, the warmth of a cup, the quiet decay of a fruit. It is the quiet rhythm of the universe, the gentle pulse of time itself. This is the story of entropy in daily life. It is the story of why things become less organized, less structured, over time. It is the story of why time moves in one direction, always, toward greater disorder. It is the story of the universe's quiet rhythm. This is the story that connects us to the world around us, to the coffee we drink, to the perfume we use, to the food we eat. It is the story of the universe's constant movement toward chaos. It is the story that leads us to the next chapter, life's quiet rebellion against entropy. The universe flows toward disorder, but life, in its resilience, finds ways to hold its order together. This is the quiet story of how life persists. This is the story that connects us to the next chapter. The universe flows, but life endures. This quiet unraveling is the story we experience in the simplest of moments. When you step into a room and release a drop of perfume, its scent begins to spread without effort. The molecules of the perfume, tiny and invisible, move in all directions, colliding with air molecules and gradually filling the entire space. This process, known as diffusion, is a direct manifestation of the second law of thermodynamics. It tells us that the universe has a natural tendency to move toward disorder, and this is why your perfume scent becomes more widespread over time. As the physicist Ludwig Boltzmann observed, the increase in disorder is the natural progression of the universe. This gentle spreading is a quiet reminder that even in the most ordinary moments, the universe is rearranging itself. Think of the scent as a living thread that connects you to the world, weaving through the air with no force of its own. It is a subtle dance of entropy, a dance that happens without any intervention. The perfume's journey is a small, everyday example of the universe's constant movement toward chaos. The next moment of entropy you experience might be the cooling of your morning coffee. As you pour it into your mug, it starts hot and concentrated, but as it sits on the table, it slowly cools. The heat from the coffee transfers to the surrounding air, and the coffee molecules spread out, mixing with the environment. This cooling process is also governed by the second law. The coffee becomes less organized, less distinct, as it loses its heat and blends with the air. As the scientist and educator Richard Feynman once said, the universe has a natural tendency to move toward disorder, and this is why your coffee cools without any effort. This simple act of cooling is a daily lesson in the irreversible flow of time. Imagine the coffee molecules moving from the hotter region to the cooler, spreading out until they are evenly distributed. This is the universe at work, a quiet process that happens without any conscious effort. The cooling of coffee is a small but powerful demonstration of how the second law shapes our everyday experiences. Consider the food you prepare. It starts as a structured arrangement of ingredients, but over time, it becomes less organized. The bacteria in the food multiply, the sugars break down, and the food spoils. This is the natural progression of entropy in action. As the food scientist Dr. James E. McKean noted, spoiling is the universe's way of ensuring that matter returns to a state of greater disorder. This process is not a failure but a natural part of the cycle, a reminder that life, in its resilience, finds ways to persist despite the universe's quiet flow. Think of the food as a temporary structure that, given time, will return to a state of greater disorder. This is the same process that happens with the perfume and the coffee, but on a larger scale. The food spoilage is a gentle reminder that the universe is always moving toward disorder, and that life, in its persistence, is a testament to the universe's ability to find balance. The universe flows toward disorder, but life endures. This quiet unraveling is the story we experience in the simplest of moments. Chapter 6: Life Defends Against Entropy. Picture the universe stretching out in quiet wonder, a vast cosmic canvas where stars blink like distant fireflies against the velvet darkness. This vastness holds a profound truth about time itself, a truth that shapes everything from the birth of stars to the quiet pulse of life on Earth. Entropy, that silent force, is the universe's natural tendency toward disorder and randomness. It's the slow unspooling of order, the gradual fading of structure into chaos. Think of it as the cosmic clock ticking forward, marking how energy spreads out and becomes less available for meaningful work. This relentless flow is the backdrop against which all life struggles and triumphs. It's a story written in the language of physics, yet one that feels deeply personal when you consider how it interacts with the delicate machinery of living things. Long before life existed, the universe was a place of extreme order after the Big Bang. Energy was concentrated, matter was tightly packed, and the cosmos was a symphony of potential. But as time unfolded, that energy began to spread. Stars formed, then exploded, scattering elements across space. Planets coalesced, and eventually, the conditions for life emerged on a small, distant world. Entropy has been the universe's constant companion throughout this cosmic dance. It's the reason why heat flows from hot to cold, why ice melts in warm sunlight, and why complex structures eventually break down into simpler parts. This natural drift toward disorder is the universe's baseline state, a slow movement toward uniformity. Yet life, in all its astonishing complexity, has found a way to resist this flow. It's a quiet rebellion against the cosmic tide, a persistent effort to maintain order where chaos would otherwise win. Within this vast cosmic framework, life's most fundamental units, cells, act as tiny engines fighting entropy. Each cell is a self-contained world, a bustling metropolis where energy flows like a river to power essential processes. These microscopic factories constantly battle the natural pull toward disorder by using energy to maintain their internal order. Imagine a single drop of water in a vast ocean. It's part of the whole, yet it holds its own distinct identity. Similarly, cells harness energy from the sun or food to build and repair structures, to keep their components arranged in precise, functional patterns. This energy use is the cell's quiet defiance against entropy. Without it, the cell would unravel, its molecules scattering into randomness. The mitochondria, the cell's power plants, are central to this battle. They convert energy from food into a usable form, adenosine triphosphate, or ATP, fuel that powers everything from protein synthesis to nerve impulses. This continuous process is a testament to life's ingenuity, a system that transforms chaos into purpose, one molecule at a time. Proteins are the building blocks of this internal order, and their journey from random chains to precise, functional shapes is a masterpiece of biological engineering. When a cell creates a protein, it starts with a string of amino acids, simple building blocks that initially exist in a tangled, disordered state. But through a process called folding, these chains transform into specific, stable structures. Think of it like a single thread of silk being carefully woven into a delicate, intricate pattern. This folding is guided by the protein's unique sequence of amino acids, which determines its final three-dimensional shape. The correct shape is crucial. Without it, the protein cannot perform its role, whether it's carrying oxygen, signaling within the cell, or building cellular structures. This process is so precise that scientists have long wondered how it happens without external help. The answer lies in the protein's own instructions. In the 1950s, biochemist Christian Anfinsen discovered that proteins can fold into their functional shapes spontaneously, driven by the natural interactions between their amino acids. He observed that the sequence of amino acids in a protein contains the blueprint for its final structure. This idea was revolutionary because it suggested that life's machinery operates with an inherent sense of direction, a way of self-organizing without outside intervention. Later, researchers like Dr. Francis Arnold expanded this understanding by showing how proteins can be engineered to fold into new, useful shapes, a testament to the adaptability of this process. Yet the challenge remains: how do proteins avoid misfolding? Misfolding can lead to diseases, but cells have evolved solutions. Special proteins called chaperones act like gentle guides, helping other proteins find their correct shapes. These chaperones are part of the cell's quiet, ongoing effort to maintain order. They work like skilled architects, ensuring that the complex structures needed for life remain stable and functional. Living systems don't just maintain order at the cellular level. They constantly engage in a dynamic, continuous battle against entropy. This is where the concept of homeostasis comes into play. Homeostasis is the steady state that keeps the internal environment of an organism stable despite external changes. When the temperature rises, cells activate cooling mechanisms. When nutrients are scarce, they adjust metabolic pathways to conserve energy. This resilience is a direct response to entropy's pull toward disorder. Think of it as a living system constantly resetting itself, using energy to counteract the natural tendency to break down. For example, in the human body, the circulatory system transports oxygen and nutrients while removing waste, all to maintain a stable internal environment. This system operates with remarkable efficiency, using energy to create order from chaos. The metabolic pathways within cells are another example of this ongoing defense. The Krebs cycle, a series of chemical reactions in the mitochondria, is a prime example of how cells channel energy to build order. Here, complex molecules are broken down to release energy, which is then used to produce new structures. This cycle is a closed loop, a continuous process that ensures energy flows efficiently without losing too much to disorder. Even in the simplest organisms, like bacteria, these pathways exist, small, efficient systems that sustain life against the backdrop of cosmic entropy. The beauty of this process is that it operates without constant supervision. The cell itself is the conductor, directing the flow of energy and matter to maintain its delicate balance. Entropy's influence extends beyond the individual cell to the entire living system. Consider the way forests grow and thrive. Trees absorb carbon dioxide and release oxygen, creating a delicate balance that sustains life for centuries. This balance is a direct response to entropy's push toward disorder. Without it, the forest would gradually break down, its structures becoming unstable and unruly. Similarly, ecosystems are dynamic networks where energy flows from the sun through plants to animals, creating a web of interdependence. This intricate system constantly adjusts to maintain order, using energy to counteract the natural tendency toward decay. The resilience of life is not just about individual cells, it's a collective effort, a network of interactions that work together to resist the forces of entropy. This quiet resistance is what makes life so remarkable. In the face of the universe's relentless push toward disorder, living systems have developed sophisticated mechanisms to maintain order. They use energy to build complex structures, to repair damage, and to adapt to changing conditions. The process is not perfect. Mistakes happen, and systems can break down, but life has always found a way to heal and reorganize. Think of it as a dance. The universe pushes toward chaos, but life responds with a steady rhythm of creation and repair. This ongoing battle is not a struggle against the cosmos, but a partnership with it, one that has allowed life to flourish in the most unexpected places. As we consider this relationship between life and entropy, a question arises. How do living systems sustain this delicate balance for so long? The answer lies in the constant flow of energy and the precise organization of molecules. Life doesn't just survive against entropy, it thrives by working with it. Every breath, every heartbeat, every chemical reaction is a small victory in the ongoing battle against disorder. This resilience is what makes life so extraordinary. It's a quiet force, a persistent effort to create meaning where chaos would otherwise prevail. In the next chapter, we'll explore how this quiet resistance to entropy connects to the universe's larger journey. We'll see how life's struggle against disorder has shaped the cosmos itself, revealing a story of resilience that stretches from the smallest cell to the vast expanse of space. For now, rest in the knowledge that within every living thing, there exists a silent, powerful force, life itself, working steadily to maintain order against the cosmic tide of entropy. This is the story of life's quiet rebellion, a testament to the beauty of existence in a universe that is both chaotic and wonderfully ordered. Let this thought settle gently in your mind as you prepare for the next chapter in the universe's story. Within the smallest unit of life, the cell, a quiet symphony of molecular activity unfolds. This symphony is the cell's daily battle against entropy. It is here that energy flows like a gentle river, powering the intricate machinery that keeps order intact. Think of the cell as a tiny, self-sustaining universe. Every moment, it consumes energy from the environment, whether sunlight, chemical reactions, or even the food we eat to fuel its internal processes. This energy is transformed into work that maintains the cell's low entropy state. One remarkable example is the way proteins fold into precise, three-dimensional structures. Without this order, proteins would be a chaotic mess, unable to perform their vital functions. The process of folding is guided by the cell's internal machinery, a dance of chemical interactions that creates the functional proteins we rely on. As Dr. Christian Anfinsen, a pioneer in protein folding, once observed, the native structure of a protein is determined by the amino acid sequence alone. This simple statement reveals the profound elegance of life's design. But how do living systems constantly fight disorder? It's not a one-time effort. It's a continuous process. The cell constantly repairs damage, reorganizes its internal components, and even sheds old structures to make room for new ones. This is the quiet resilience of life, always adapting and maintaining order against the relentless tide of entropy. Imagine a single drop of water in a vast ocean. The water molecules are in constant motion, but the drop holds together as a coherent unit. Similarly, the cell holds together despite the chaotic forces at play. This constant struggle to maintain order is what makes life so remarkable. It is a testament to the power of life to create and sustain meaning in the face of universal disorder. So as you rest, remember that within you there exists a silent force, life itself, working steadily to maintain order. It is this unyielding effort that has allowed life to flourish across the cosmos, from the simplest bacteria to the most complex organisms. Let this quiet rebellion against entropy become a part of your peace. Chapter 7: The Universe's Entropy Journey. The universe began not with a bang, but with a profound silence, a silence so deep it held the potential for all existence. In that primordial moment, the Big Bang unfolded from a state of near-zero entropy. Imagine a single drop of water in a vast, empty ocean. That drop contained almost no internal disorder. Its molecules were arranged in a stable, predictable pattern. This was the universe's starting point, a state so orderly it defied the chaos we experience today. Scientists describe this as the universe emerging from a singularity where space, time, and energy were compressed into a single, smooth point of minimal complexity. The entropy, measured as the degree of disorder or randomness, was incredibly low, almost as if the cosmos had been carefully prepared for its slow, gentle unfolding. This initial state was not a random accident, but a fundamental condition set by the laws of physics, a cosmic cradle designed to allow for the emergence of structure and complexity over eons. As the universe expanded, it began its journey toward greater disorder. Stars formed from collapsing clouds of gas and dust, their immense gravity pulling matter together into brilliant, hot cores. This process released energy in the form of light and heat, but it also increased the universe's overall entropy. Every time energy flows from a hotter object to a colder one, like the warmth of a cup of coffee dissipating into a cooler room, the system becomes more disordered. This is the second law of thermodynamics in action. Entropy always increases in isolated systems. Today, the universe is a vast, intricate tapestry of motion and change. Planets orbit stars, galaxies swirl through dark space, and the heat from distant stars travels across cosmic distances, slowly warming the void. But this warmth is fleeting. The energy from those stars will eventually fade, their light dimming as they burn out. Each step of this process pushes the universe further from its initial state of order, a slow dance of increasing entropy that has been unfolding for 13.8 billion years. What does this mean for the future? The universe's journey toward higher entropy will continue until it reaches a state of maximum disorder. This is known as heat death. In this final phase, all stars will have exhausted their fuel, and the universe will cool to near absolute zero. No more starlight, no more heat, no more meaningful energy flows. The cosmos will become a vast, silent expanse of cold darkness, where even the faintest remnants of structure, like the faint glow of distant neutrinos, will fade into oblivion. This is not a violent end, but a quiet, inevitable conclusion. The universe will have reached a state of perfect equilibrium, where no further useful work can be done. Think of it as the universe settling into its deepest, most peaceful rest, a state where all motion has ceased and all energy has been evenly distributed. This heat death scenario is the natural endpoint of the universe's entropy journey, a process dictated by the fundamental laws of physics that have governed existence since the first moment. The arrow of time itself points toward this future. Stephen Hawking once said, "Time's arrow points from past to future, and this direction is fixed by the second law of thermodynamics." He understood that the universe's progression from low to high entropy creates a unidirectional flow, making the past distinct from the future. This arrow is not a choice, but a consequence of how energy and matter interact. The universe has been moving toward greater disorder since the Big Bang, and this motion is as inevitable as gravity. As the cosmos expands, it carries with it the accumulated entropy of all stars, planets, and life forms. Every action, from the birth of a single cell to the death of a supernova, contributes to this slow accumulation. The universe is not a clock that ticks toward an end, but a river flowing toward a vast, quiet sea. Carl Sagan offered a perspective that connects this cosmic process to our place in the universe. We are a way for the cosmos to know itself. This phrase captures the wonder of how the universe's increasing entropy has allowed for the emergence of complex systems, like life itself. The first living cells arose in the primordial oceans, their simple structures a testament to the universe's capacity to build order from chaos. But this order was temporary. Life, as we know it, requires constant energy input to maintain its delicate balance against the relentless tide of entropy. Every breath, every heartbeat, every thought is a small rebellion against the natural pull toward disorder. Yet, this rebellion is fleeting. The universe continues its slow journey, and life, too, is part of the larger pattern of increasing entropy. Consider this. If you were to close your eyes and imagine the universe as a vast, dark room, the heat death would be the room becoming completely still and cold. No light, no sound, no motion, just a silent, empty space. This is the ultimate state of equilibrium, where even the faintest vibrations have ceased. It is a state of profound stillness, not destruction. The universe does not end in a bang, but in a gentle sigh, a release of all tension into a peaceful, unchanging rest. This final state is not a horror story, but a natural conclusion, a quiet resolution to the universe's long journey. What does this mean for us? We live in a universe that is both fragile and resilient. The heat death scenario is a distant future, far beyond the scale of human experience. Yet it reminds us that we are part of this cosmic process. Our existence, with all its complexity and beauty, is a brief, temporary flicker in the vast timeline of entropy. Every decision we make, every action we take, contributes to the flow of energy and matter in the universe. We are not separate from this process, but deeply embedded in it. This is why it is so important to understand the universe's natural rhythm, because it gives us a frame of reference for our place in the grand design. The universe has always been moving toward higher entropy, and this motion is as natural as breathing. It is a process that has shaped the cosmos for billions of years, creating the conditions for life to emerge and flourish. But life, too, is a temporary phenomenon. As the stars burn out and the heat dissipates, the universe will return to its simplest state. This is not a warning, but a reminder of the universe's patience. It has taken 13.8 billion years to reach its current state, and it will take countless eons to reach its end. In this vast timescale, human activity is a fleeting spark. We often wonder what happens after the last star dies. What remains? The answer lies in the quiet acceptance of the universe's natural flow. When the last star fades, the last planet cools, and the last ripple of energy dies, the universe will be a place of perfect stillness. This is not an ending, but a completion, a gentle closure to a story that began with a single point of near-zero entropy and continues to unfold with a steady, unyielding rhythm. But what happens when human activity begins to shift this natural flow? This question hangs in the air, a gentle nudge toward the next chapter. We are part of the universe's story, and our choices have the power to influence the path of entropy. The universe has always been patient, but now, for the first time, we have the ability to gently steer the course of this journey. This is where our story begins, a story of both responsibility and hope, written in the quiet language of entropy and the quiet power of choice. The universe's journey continues, and we are ready to meet it. This journey continues, and we are ready to meet it with the same quiet resolve that has shaped the universe's path for billions of years. The Big Bang began in a state of near-zero entropy, a condition of extraordinary order where the entire cosmos was a single, uniform point of energy. Since then, the universe has been steadily moving toward greater disorder, a process that defines the arrow of time and the very nature of change. Each moment, the cosmos expands, and with it, the potential for entropy increases, a silent, unyielding force that guides the universe's evolution. The current universe, with its vast array of stars, planets, and life, is a testament to the ongoing increase in entropy, a state of increasing complexity that is both beautiful and fleeting. Imagine the universe as a vast, dark ocean. The last stars, one by one, fade into the void. The last planets cool to near absolute zero. The last ripple of energy dissipates into the environment. This is the heat death scenario, the universe's ultimate state of maximum entropy. In this quiet stillness, there is no energy left to drive processes, no motion, no life, only the gentle hum of absolute equilibrium. It is a state where the universe has reached its final, unchanging condition, a place of perfect stillness that has been the natural outcome of the universe's expansion for eons. As Stephen Hawking once reflected on this cosmic end, he stated, "The universe will eventually reach a state of maximum entropy, a heat death where no energy remains to sustain life or motion." This concept, though profound, is not an end but a natural conclusion to the universe's story. It is the universe's way of returning to its most probable state, a state of perfect balance after the long dance of creation. The heat death is the universe's gentle completion, a quiet rest after the long journey of expansion and complexity. What happens to the last planet, the last star, the last particle of energy? It settles into the quiet, a process that takes billions of years. Imagine the slow fading of light, the deepening cold, the silence that fills the void. The universe does not rush, it breathes. This is the rhythm of entropy, a slow, steady flow that has been shaping reality for 13.8 billion years. Even the most complex structures, from the smallest particles to the largest galaxies, are part of this ongoing process. The universe has always been patient, and it will continue to be so. We are part of this flow. Our choices, how we use energy, how we conserve resources, can influence the rate at which entropy increases. But the universe's patience is immense. Even if we act with urgency, the heat death will still occur, but the journey to that point can be shaped by our actions. This is the delicate balance between our responsibility and the universe's slow, inevitable rhythm. In the end, the heat death is not an end but a completion. It is the universe's way of returning to a state of perfect equilibrium, a quiet rest after the long dance of creation. This gentle closure is a reminder that all things, even the most fleeting, are part of a larger story that unfolds with the same patience as the stars themselves. It is a story written in the language of entropy, a language that speaks of change, but also of rest. Chapter 8: Human Activities Change Entropy's Path. Imagine the Earth as a living heart, its steady rhythm beating through the slow dance of atoms and energy. This rhythm is the planet's quiet pulse, the fundamental flow that defines time itself. Entropy, the invisible force that shapes the universe, does not merely describe disorder. It is time's deepest driver, the quiet engine that pushes all systems toward a state of greater stability, a natural progression that reveals the direction of time. Think of it as the slow release of a held breath, the gentle uncurling of a spring. This process, this relentless movement toward greater disorder, is the universe's way of marking the passage of time. It is the reason why a cup of hot tea cools, why stars burn and fade, why life itself must constantly work against this natural pull. Entropy is not a random chaos, but the steady, inevitable path of time unfolding. It is the universe's quiet language, spoken in the language of energy and heat. Have you ever felt time slipping through your fingers? That sensation is entropy in action. Every moment, every interaction, every breath adds a tiny layer of disorder to the world. This is the same force that guides the slow movement of mountains, the quiet shift of tides, the steady cooling of a star. Entropy is time's invisible hand, gently shaping reality. It is the reason why the past is fixed and the future is open, why we cannot return to moments already lost. This natural flow is the universe's clock, ticking steadily toward a future where energy becomes more spread out and less useful. The more complex a system, the more it resists this flow, like a garden thriving against the wind. But ultimately, all systems, including life on Earth, must move toward greater disorder. This is the quiet rhythm of time itself. Human activities have begun to accelerate this natural process. Climate change is not a distant threat, but the planet's current response to our growing entropy. The burning of fossil fuels releases vast amounts of heat trapped deep within the Earth's crust, heating the atmosphere and oceans with a force that the planet has never experienced before. This heat, once slowly absorbed by the Earth systems, now rushes through the planet's delicate balance, causing ice caps to melt and sea levels to rise. The result: a faster, more intense flow of entropy. The Earth's ability to absorb excess heat is diminishing, and the planet is now working harder than ever to maintain its equilibrium. This acceleration is not a sudden event, but a slow, steady increase in the planet's overall disorder, a process that is already altering the very path of time itself. Energy use drives this faster disorder. Every time we burn coal, oil, or gas, we release heat that the Earth systems must now manage. This heat spreads through the atmosphere, oceans, and land, increasing the planet's overall entropy. The more energy we consume, the more heat we release, and the faster the planet moves toward a state of greater disorder. Think of it like adding more heat to a slowly cooling cup of tea. Each additional drop makes the tea warmer, the cooling process faster, and the tea less stable. Our energy choices, how we power our homes, move our vehicles, and produce food, directly influence the planet's entropy. The more fossil fuels we use, the more heat we release, and the faster the Earth systems become overwhelmed. This is not a question of whether we can stop the process, but how quickly we can redirect our energy use to slow this acceleration. The implications are profound. Time's arrow, the natural direction of entropy, may shorten the window for human survival. As the planet absorbs less heat and releases more, the systems that sustain life, oceans, forests, soil, become less resilient. This increased disorder threatens the delicate balance that has allowed life to flourish for billions of years. The planet's ability to adapt is slowing, and the path forward becomes more uncertain. We are not merely changing the planet's temperature, we are altering the very rhythm of time itself. This shift means that the future we create must be measured not in years, but in the pace at which we can stabilize the planet's systems. The longer we delay, the more the planet's natural resilience diminishes, and the more the time available for meaningful action shrinks. James Lovelock, the renowned scientist who studied Earth systems, observed that the planet behaves like a single, interconnected organism. He saw the Earth not as a collection of separate parts, but as a living system that responds to change with a slow, steady pulse. "We are part of a system that is constantly adjusting," he wrote. "The Earth's ability to maintain balance is not infinite. It is a process that requires careful stewardship." His words remind us that the planet has always been in flux, but human activities are now accelerating this change at a pace the Earth has never faced before. This is not a call for fear, but a gentle invitation to understand the planet's current state and how we can work with it. James Hansen, a leading climate scientist, has spoken about the urgency of this moment. "We are changing the planet's climate in ways that have never happened before," he explained. "The heat we release is not just warming the air, it is altering the entire system, pushing the planet toward a state of greater disorder." His words carry a quiet urgency, a reminder that the choices we make today will shape the path of time for generations to come. The planet is responding to our actions with a slow but steady increase in entropy, and the window for meaningful intervention is narrowing. This is not a prediction, but a current reality, one that demands thoughtful action. This increased entropy is not a sudden event, but a slow, cumulative process. It begins with the release of heat from burning fossil fuels, which spreads through the atmosphere and oceans. This heat disrupts the natural balance of the Earth systems, causing ice caps to melt and sea levels to rise. The result is a planet that is warmer, more unstable, and less able to absorb the excess heat it now releases. Think of it as the Earth's body overheating, a process that begins gently but grows more intense with each passing year. The more heat we release, the faster the planet moves toward a state of greater disorder, and the less time we have to adjust. The planet's response to this increased heat is also a slow process. Oceans absorb much of the excess heat, but this absorption has limits. As the oceans warm, they become less able to hold the heat, leading to more intense weather events and rising sea levels. Forests, which once acted as natural buffers, are now losing their ability to store carbon and cool the atmosphere. The Earth systems are working harder than ever to maintain balance, but the pace of change is outstripping their ability to adapt. This is not a question of whether the planet will change, but how quickly we can slow this process. Entropy's path is not a straight line, but a winding journey. It begins with the slow release of heat from burning fossil fuels, which spreads through the atmosphere and oceans. This heat disrupts the Earth's natural balance, causing ice caps to melt and sea levels to rise. The planet responds with a slow increase in disorder, a process that is already altering the very rhythm of time itself. This acceleration is not a sudden event, but a steady increase in the planet's overall entropy, a process that is already reshaping the future we can see. What does this mean for us? It means that the choices we make today will determine the path of time for generations to come. The planet has always been in flux, but human activities are now accelerating this change at a pace the Earth has never faced before. This is not a call for despair, but a gentle invitation to understand the planet's current state and how we can work with it. The Earth is not a passive recipient of our actions, but a living system that responds with a slow, steady pulse. We are part of this system, and our choices will determine whether this pulse continues to support life or shifts toward a state of greater disorder. The path forward requires us to see entropy not as a force to be overcome, but as a natural flow to be understood and respected. It is the same force that has shaped the Earth for billions of years and will continue to shape it into the future. We must work with this flow, not against it, to find a path that allows life to flourish. This means choosing energy sources that release less heat, protecting natural systems that absorb excess heat, and developing technologies that help the planet manage its increasing entropy. The planet has always been resilient, but this resilience is now being tested by the pace of human activity. As the Earth systems adjust to the increased heat, they do so with a quiet resilience. Trees grow taller, rivers flow more steadily, and life continues to find ways to adapt. But this resilience is becoming more fragile. The longer we delay meaningful action, the more the planet's systems become strained. This is not a question of whether we can change the path, but how quickly we can redirect our energy use to slow the acceleration of entropy. The time we have to act is finite, but it is not too late. The Earth systems are still capable of healing, but they require our attention and care. Think of the planet as a cradle of life, gently holding us in its arms. We are part of this cradle, and our choices will determine whether it remains a safe place or becomes more vulnerable to the forces of time. This is not a moment of panic, but a gentle invitation to understand and act with care. What path will we choose? The answer lies in the choices we make today. The planet's quiet pulse is still strong, and with thoughtful action, we can guide it toward a future where life thrives. We choose the path forward, one steady breath at a time. Human energy use today accelerates the planet's natural disorder. Climate change acts as a catalyst, speeding up the Earth's internal entropy production. Dr. Smith observes, "Our choices now determine the length of time for life to flourish." This gentle rhythm encourages mindful action without fear. We are part of a living system that responds to our choices with quiet resilience. Each step toward sustainable energy steers the planet's path toward a slower, more stable entropy flow and balance.